Hello, this is the probably the last topic. It is the last topic that I'm going to talk about, lah, unless you guys request for more. Okay, so I'm not going to talk about regression because I think it's very easy and yeah, nothing much insightful for me to go through, lah. Okay, so forgot what I say. Okay, hypothesis testing. Okay, let's do it. Let me explain the concept of hypothesis testing to you guys. Then after that, as we want to get the information necessary for hypothesis testing, we will slowly relate it back to discrete random variable sampling and all the good stuff lah. Okay, yeah, normal distribution. Did I miss out anything? Let me take a look. Yeah. Okay, so let's begin. I will begin with giving you a scenario, an example. Say today is your first day in school, okay? Then you look around, okay? Then you realize that most people are quite tall, okay? Then after that, you go and find out, okay, from the principal, okay, what is the average height of the students, okay? So if the principal says that the average height is 175, okay, so he claimed that the average height is 175 cm, okay, but you no, you say that the average height is 168 cm, okay, but you look around your class, okay, then you find that 168 doesn't seem to be the average height, okay, and you ask your 20 of your friends, okay, what's their height individually, okay, so some will be 155, some will be, I don't know, 185, etc. And then eventually you calculate, and the answer you get is 170 cm. Okay, so this is calculated out. Okay, that means that we the other way to say is realized value. Okay, so realized value, right, means that it has certain probability associated with. It comes from a random variable, okay, but then that random variable haven't the sample haven't been extracted, so it is a variable with a probability. Now you really go and conduct the experiment already, then you have the actual data. Okay, that means to say, right, if you go and collect another 20 sample, right, this realized value may varies. Okay, so now you are doubting yourself, okay, on what is the chances of you getting this what is the chances of you getting this sample, okay, important yeah, remember this okay, it's about testing the likelihood of you obtaining that sample, okay, but we know that, right, okay, the principal also claimed that it's a normal distribution okay, but we know that in a normal distribution, right, a point, okay, the probability is 0. Okay, that's why we cannot use this to calculate, to give you the sense of whether your the sense of how likely you obtain the sample, because it will always be 0 whenever you put equal here. Okay, so we kind of need a measure. Okay, so we in this case find let's try this, okay, and then see what's the chance of you getting this. Okay, so student may ask, how come, why not like that leh? Why bigger than equal leh? Why lesser than equal, right? Okay, that's where you always see, okay, here h naught dot dot, then after that h1 dot dot, then why sometimes is more than 168, then why sometimes is less than 168. Okay, let me explain. Okay, you need some form of measure, right, that is coherence with the different set of realized value. Okay, that means that, okay, you may have another set of value that is 171. And 171, right, naturally the percentage need to be lesser. That's why we need to use this sign. Okay, if else we use this sign, it will contradict. Okay, it doesn't make sense, right, that the probability of this is higher than this. Okay, yeah, the probability of this should be lower. Okay, that's why it's more than equal. Okay, why is this more why is this like more, why is this less, right? It's because your center is here, 168. Okay, that's why yeah, 171 has a lesser probability. Okay, so it depends on the questions. Okay, and it depends on the data you got lah. Okay, to use bigger or uh, lesser, bigger than or lesser than. Okay, but just generally, this is a form of measure, okay, to tell you how likely that you obtain that sample. Okay, so we call this p-value. Okay, so this p-value, right, um, you cannot calculate out uh, um, you okay, now go back to normal distribution. Okay, normal distribution says that, right, okay, to calculate this kind of thing, right, okay, you need a distribution in the first place, means you need a parameter. Okay, so what is the parameter? Okay, so the parameter requires you to form a few things. Okay, firstly, you need to know what is your distribution. Okay, maybe the student height is not normal distribution, maybe it's something else. Okay, um, and then you need the information inside these parameters. Okay, so I say again, to calculate probability, you need the type of distribution and the parameters. Okay, so it always revolve around this. Okay, what is the range you want to get? What is the parameters? And then what's the value of p? Okay, the other ways is just substituting one of them as unknown. Okay, so that will relate to your sampling topic. Okay, so say my x, if principal, so there's a few scenario. Okay, first scenario, right, principal assume normal. Okay, then example like that, like that, like that, 168, right? Okay, then after that, say this one is pi square. Later I want to talk about the this is going to be quite a long lecture lesson, so yeah, bear with it. Okay, so normal distribution tells us that if this is like that, then okay, what is that? Okay, normal distribution tells us that this plus by, right, okay, equals to a expectation of x plus b expectation of y, right? Then variance of a x equals to a square variance of x. Make sense? Yes. Okay, that's why from with this, right, we should be able to produce the distribution of x bar. Okay, So expectation of x bar, okay, is equals to expectation of x1 plus dot 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 plus xn divided by n. So making use of this property, okay, we will know that it is equals to 168, okay, plus 168 plus 168, okay, then divide by n. Okay, so how many 168 are there here? Okay, if you are good with your multiplication, you study really hard for your probability, right? You'll know that there is 168, n number of 168. Okay, so the expectation of this is 168. So here is 168. Okay, after that, variance of this one, okay, equals to variance of x1 plus dot 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 plus xn divided by n. Okay, so equals to 1 over n squared variance of x. Okay, so equals to, sorry, one variance of x1 plus x2, etc. Okay, so become n times of variance of x. Okay, then after that, divide by n squared. Okay, that's why it's equal to variance of x divided by n. That's why here is 5 squared divided by 20. Okay, so that's the first scenario where the principal tell you that it's normal. Okay, the second scenario is never say anything. Okay, yeah, didn't mention. Okay, or they say is some non-normal lah. Okay, maybe it's binomial or what, or some things we never come across before. Okay, just it's not normal. Okay, the distribution is some kind of distribution. So if they say this, okay, you need to use CLT. Take note, always form the full picture. So in exam, right, what you need to do, I say again, this is important. In exam, what you need to do is read through the questions and look out for whether they say normal or they never say anything, or yeah, stuff like that. Okay, so if they never say anything or they say it's binomial, you need to use CLT. Okay, so CLT, what is CLT? Okay, CLT is not an approximation. That's why sometimes the question will ask, is sorry, my bad, it's not an assumption. Okay, that's why sometimes the question will ask, is any assumption needed or not? Okay, then yeah, then you will say no, because when the size is large, it will tend to a CLT naturally lah. Okay, so if I never remember wrongly, the standardized criteria is n need to be 30. Okay, so what does CLT really means, right, is that imagine you got your x is like that. Okay, so you got x1, x2, etc. It's all like that. Okay, so that means if you add them up together, sum them up, the peak will get bigger. Okay, then the slope will get more smoother. Okay, so at the start, okay, it will, here will still be very peak, then here yeah, smoother. Again, then after that, eventually here will be more smoother as well as you add up. That's why it will tends towards normal distribution. Okay, approximately. Okay, these words is important. Okay, so it's not an assumption. but naturally it will just happen. It will tend to exceed approximately. Okay, so that's the meaning of CLTR. Okay, so this scenario, right, you need n to be more than 30. Okay. Okay, then the third kind of scenario, right, is that your sample size is less than 30. Your sample is very small. Okay, so the only way you can solve this I say again hypothesis testing is to find the chance of you getting that sample. You go and get all this data, then you question yourself, what's the likelihood of me getting it? Okay, so you want to find out the probability means you need a distribution. Okay, so how to form that distribution, right? Okay, if n is small and n is not, they never say n is normal, they never say okay, then you need to assume, sorry, n is small, and they never say the distribution is normal, then you need to assume x is normal. You need to assume then you can find this value, find the p-value. Okay, so with that you will be able, okay, with that you want to find p probability, you will need the mean, you will need the distribution, the kind of distribution. You will need a mean. The mean is from the assumption. Okay, so why is the mean from the assumption, right? Okay, is because the principal tell you this data, okay, and then you go and carry out, you assume that that is correct, assuming the principal is correct, and you still, then you get a data that is say 0.00001. Okay, the chances of you getting that is very, very, very small. Okay, using what she say lah. So you start to question, whether she's right or not. Okay, the official data is right or not. Okay, so how much is small? Is like that small or not? Okay, Apple may have a different criteria with Samsung. Okay, is like that good or not? Okay, so it depends on the level of significance level. Okay, that's why the company, they will set their, or the researcher will set their significance level lah. Okay, so some will set it to be less than 5%. Okay, then your data say then you need to reject the official data, because the chances of you getting that sample is so small. You already go and carry out the experiment and you got it. Okay, so most likely that distribution figure is wrong. Okay, most likely the central tendency already shifted. Okay, yeah, so that's the whole concept of hypothesis testing. Okay, so just now I say already, okay, to form the p-value, okay, you need to know the distribution. Okay, after that, why is that mean that claim that they give you? Okay, now the third one I want to talk about, right, is this thing. Okay, variance. Okay, so this one we will backtrack a bit, right, to talk about what really is variance. Okay, because a lot of times there'll be a lot of different ways that the question can ask, and then there isn't, that's why students get very confused uh, when calculating the unbiased estimator of the population variance. Okay, so let's talk about what is variance. Okay, so go back to basic. Okay, basic is we got a lot of data, right? That's the most basic one. Okay, so this data, right, there will be a mean. Okay, so variance is about the spread of that data. Okay, like how far away are them. Okay, but it's very difficult to talk about individual component. Say this is a number line. Okay, and then some is here, some is here, some is here. Yeah, so how do you really say how far? Are you going to compare to this thing, this one compare this one, or this one compare this one, etc.? Okay, that's why we need to use the concept of X bar. Okay, then after that, compare everyone to X bar to be able to tell the level of dispersion or spreadness. Okay, so the difference between them, and then because X bar may be more than or less than your sample. For example, everything over here, right, X bar is smaller. Everything over here, X bar is bigger. Okay, so we need to square it. Okay, to because we are measuring the spread. Okay, yeah, that's why like positive and negative value, we are only interested in the magnitude of it. Okay, that's why we square everything. Okay, so after you square everything already, right, then how to what's of course you like this one very far, okay, this one very short. So to account all of this spread, right, we need to divide the spread, okay, which is divide all these value you square it first. Okay, their difference you square it first. After that, you add them together, then you divide to find the average spread. Okay, so that is the meaning of variance. Okay, that's why sometimes question give you like like that. Okay, what is x minus x bar, right? Sometimes they will give you this. Okay, then you will be able to better understand it. Yeah. Okay, then yeah. So based on just now what I say, right, is okay, there are difference, then you square all the difference, then you add them out and you find the average. Okay, so this will be variance of x. Okay, so after that, right, some mathematician, right, they go and expand this thing square. Okay, and then right, what they found out is that after they expand this thing, do, right, what they found out is that this is equals to this eventually. Okay, okay, so what does this mean? Okay, this mean your all these value, okay, you go and square every individual one of them, then you go and find the average of this square minus away the square of your sample. It's gonna give you that variance anyway. Okay, so this is not intuitive, as in like to the concept of spreadness. Okay, but if you try to digest the meaning of this, right, and put it into this diagram form, right, you will be able to memorize or understand the equation better. Okay, so that's it for this part. Yeah, why am I going through this? Is to tell you what is variance. After you know what is variance, okay, variance is variance. Okay, then there is population and there is sample. Okay, so let's say my population is this big. Okay, my sample only this big. Okay, so we can see this as just a group of data with a variance. Okay, so this group of data got variance. This group of data also have variance. So What do you call this? We call this population variance. Okay. Then we call this sample variance. Okay, so how you calculate them, right, is no difference from how you calculate this thing. Okay, how you calculate this thing. Okay, just take element wise, right, individually, and then find the sample and then the spreadness, etc. Okay, it's no difference. Okay, but if you don't have all the elements, okay, you only have a small part of the data. Okay, you need to do an estimation. What do? You kind of need to so-called, I like to use this way of understanding okay. You need to kind of blow out your data to so that it matches with the population variance. Okay, that's why we times n over n minus 1. Okay, can understand that? Okay, so variance is variance. The sample will have its own variance, population will have its own variance. Then after that, if you only have sample variance, you need to blow it out. That's why why I say blow it out, right, is because sometimes students think whether is it n minus 1 over n or n over n minus 1. Okay, so if this one, then it will be slightly more than 1 okay, so that means blowing it out okay, so sample variance times n over n minus 1, right? Okay, is your unbiased estimator of your population variance. Okay, it is just an estimator. Okay, not the actual variance. Okay, so with that, why I thought about all this, okay, it's important. Sometimes the question can be very tricky. Okay, they can just say variance is what? They go and draw a sample and variance is what? Okay, and then you need to interpret on your own that, oh, that one sample variance. Okay, or sometimes you can draw a sample and then they full stop. Yeah, after that, yeah, then after that, the variance of the distribution is what? Okay, then that is population variance. Okay, so look at the details. Yeah, I cannot emphasize this enough. This is important. Okay, don't overlook it. Did I miss out anything? Yeah. Okay. So again, to summarize everything, okay, hypothesis testing is to find probability of you getting that sample. Okay, to find probability, you need what distribution is it? Okay, that's why it come. Then you need to look at the question, whether is it normal, whether they say it's normal already, whether they never say whether the sample size is big and the sample size is small. Okay, then after that, you need to look at your variance. Okay, which data, whether they provide population variance already or they provide just sample variance. And a lot of times it can be very tricky, the wording. You need to read very carefully. That's all. Read. Okay. Yeah. Okay. Now let's talk about the other kind of questions. Okay, where you are not trying to show that we reject this or we don't reject. Okay, you are trying to find a range of value or range of value. Okay. So just now I say that, right. Okay, all your calculation, right, revolve around this thing, this apple. Okay, then revolve around take notice of this. I always write x bar. It will never be a case of probability of x. Okay, because you are measuring the likelihood of the sample you draw. That's why it's x bar. Okay, so this x bar some distribution, okay, then this one is some orange, then this one is some pear. Okay, so yeah, it depends on what is the unknown. Okay, sometimes they will ask the range of value of the mean, okay, or the range of value of variance. It depends. It really depends. Okay, so um, okay, let's break it down into case by case. Okay, scenario where this one is unknown. Okay, then your this thing is known. Example, okay. So if your this one don't know okay, but this one is no you can use your calculator inverse norm straight away. Sorry. Okay, so other than these three data, right? Okay, this data is some data lah. Okay, so sometimes they can say, oh, they go and conduct the experiment, right? Then after that, they reject the sample. Okay, so if reject the sample, right, means that the chances of you getting it is very little. Okay, that's why less than the significance level. Okay, so it's always play in with these four. In fact, five lah. Okay, but this one may be sigma unknown or n unknown, depends. Okay, so yeah, it's just playing with this lah. Okay, so they can tell you is reject or not reject, those kind of stuff. Okay, so let's say we in this example, right, we say that the student reject your sample. Okay, so it's less, then they tell you the significance is 0.05. Okay, so in this scenario, right, you can just do inverse norm already. Okay, inverse norm. Okay, then you guys are very privileged. Okay, by putting inside the value of x bar of I don't know. Let me see inverse norm. Yeah. Okay. By putting in x bar, by putting in by putting in mu, by putting it sigma, okay, by putting it this area, right? Okay, you guys will know what this need to be. Okay, so like that. Okay, I don't skip this. Okay, you guys need to learn how to draw this diagram. You guys have to learn. Okay, have to must, no negotiation. Okay, so over here, right, what does this represent, right? This thing represent, okay, if you think of 0.05, okay, it can either be here or here. Okay, so because this one is bigger, right? Okay, that's why we are talking about here. Okay, that's why your calculator, right, you click, you must click the right. Okay, can okay, then they will give you the answer lah. Okay, yeah, this right, left, etc., right, it will always correspond to the shaded area. Okay, yeah, so if it's a two-tube test, okay, it's either you change this to 0.025, right? Then after that you use right, okay, or you key in this 0.975. No, sorry, 95. Okay, but it's also dependent on whether your here is the mod is less than or greater than. Okay, but you get what I mean. Okay, just know that, okay, that calculator inside, okay, whatever they do, is it right, left, etc., right, okay, correspond to the shaded area. Okay, so with that, you have your this value, you have your this value, you have your area. Okay, this value, you have this value. Okay, then you will be able to find this. Okay, inverse norm is to find this one. I say again, inverse norm is to find this. Okay, so but now let's say in another situation where the mu become unknown. Okay, so this one is unknown, this one is known. This one also known. Okay, like that. Okay, so what does this need to be, right? Okay, we cannot use inverse norm anymore, because imagine in your calculator, this thing, okay, you don't know what to key in for this, so you cannot do anything. Okay, that's why we need to learn standardization. Okay, which is x bar minus question mark over 2 over square root 30, then okay, how I know this? Okay, it's simple. Okay, you got any equality, right? Okay, whatever you do on the left, you do on the right. That's it. Okay. Um, yeah, okay. So this one is still be the same thing, because that likelihood should be the same. I understand what I'm saying. If finding this probability, right, if you shift this x value by 1, right, then what is the value of this, right? It should be the same probability. If you wear a shoes, right, what's the probability of the student height being 180 should be the same as the student height being 179 before wearing the 1cm shoes. Okay, that group of students is the same. Okay, that's why this probability remains the same. And so why I say this is important, right, is that now with this return, you can form, you know what to write for this, and you know what to write for this. Okay, if you know what to write for these two, right, these two is 0 and 1, standardization. Okay, so if you can fit something into this, right, just now what I say inverse norm is to find your this one. Okay, means you can find your this one by using that operation, inverse norm operation. Okay, because now this and this already known. Okay, then after that, this one will be more than or something or less than or something. Draw this thing, and then you will know whether it's more than or less than. Okay, then after that, that calculator, that inverse on that value, right? Okay, put it inside here, then you will solve for the unknown. Okay, so this is the case for, be it the unknown is this one, the unknown is this one, the unknown is this one, or yeah. Okay, so that's it for your hypothesis testing. Okay, yeah, so it's been a good experience to share some of the things that I find very useful. Growing up, I don't really have, I don't really, am not really that smart. I face a lot of struggles in my work. Okay, so then nowadays when I teach students, it's always that, oh my god, they could have do something, prevent themselves from so much stress and so much unhappiness with the result. Okay, that little things, right, is those stuff that I always talk about in the videos. Okay, so go work on it. I always tell my students, uh, it's really whether you make that correct turn. Sometimes it's not about how 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 far you go. It's about realizing that and make the correct turn, make the correct turn. And then sometimes students can pick it up so fast, okay, because they catch it. Okay, so spend some time to work on the little things that I say, and I hope that it benefit you. Okay, so that's all. Moving on, what's the direction for this channel, right? I'm gonna do some past year math paper. I'm thinking of going live um, while doing that. Okay, so why am I going live? Okay, and what's my, do I have targeted marks that I want to get? Okay, yes, I have a targeted marks. Okay, because I, when I advertise my service, I always tell people that I get when I was a student, then I get 90%, more than 90%. So I kind of want to show that it can be done. Okay, but can it be done every time? Is there days that I'm off from? Yes, absolutely. Okay, so um, yeah, why am I going live? Is that I would kind of want to simulate that exam pressure lah. Okay, you guys kind of know that when you get to the exam, it's like a giant stone, a giant rock, right, crushing on you. Okay, so I kind of want to simulate that. And then, yeah, so what happens if I don't get 90%? Okay, yeah, it's fine. Okay, I also trying through this, right, I also trying to um, relate myself with the students that it's okay to not do well. Okay, the problem is we think that we need, it's a wave. Okay, our life is a wave. Okay, the, and it's not, it's really normal to, life will just be ups and downs, ups and downs, ups and downs. Okay, the only problem is we keep thinking that we need to be here when we are here. That is where we start to face a lot of disharmony. Okay, what's going to happen here, right, is there will be introspection, okay, to prepare you for the wake up. Okay, so once you realize that, right, okay, you will take opportunity of this, okay, and learn from all these mistakes. Okay, and then when you are here, then get ready to go down. Yeah, but just try to understand it's a cycle. Okay, so yeah, so that's why I put the risk of doing it, and then yeah, and if I don't get it, it's fine. Okay, so that's all for all these lectures, and I see you in the next one. Bye bye. Oh yeah, so the videos of me doing other papers, um, it may be for members only. I don't know. I may do a few to uh, show you guys that it can be done. Okay, so why am I monetizing this? Okay, it's because effort is spent, and then yeah, I go through a lot of effort to redigest everything. Okay, so do understand that yeah, I need I need a living as well. Okay, so am I encouraging students to just copy from these videos. No, okay. That's why I always say that you guys need to go and pick out the little details. Okay, so only watch these videos, right, if you guys are still struggling with um, figuring out what is the perspective you should look at. Okay, and then the other thing is why I'm doing it, solving this question is that um, problem solving is another kind of skills, okay, that you need to train. Okay, so yeah, and I decided to make it into a members video because I don't want it to circulate too much and causing and as a result affecting other tutors lah. Okay, so if you guys are members, I will see you there. Then if you guys are not, continue to engage, continue to share with me how you like it, or continue to share with me how a different approach you take to understand. Okay, been a joy to teach you guys, and I appreciate you guys to hear me out. Okay, so yeah, see you guys whenever. Bye bye.